This video is on topic 2.6, resonance and formal charge. And today I'm going to talk about how formal charges can be used to determine the best Lewis diagram for a molecule. My name is Alice Pudi, and I'm happy to be back with you on AP Daily. If you have a structure like carbon dioxide, where there's multiple ways to draw it, satisfying the octet rule. So one way is you could draw it so that the carbon is double bonded to both oxygens, or you could draw it where the carbon is triple bonded to one oxygen and single bonded to another oxygen. Both of these are valid because in both diagrams, the octet rule is followed. So every atom has 8 electrons around it. So how can we predict which one is the dominant structure here? To do this, we need to look at the concept of formal charge. Formal charge is the hypothetical charge an atom would have if all the atoms had the same electronegativity. To calculate the formal charge, we first assign electrons to each atom in the diagram, and every unshared electron is fully assigned to the atom in which they are found. And in a bond, half of the electrons are assigned to each atom in the bond. If we look at carbon dioxide, the 2 lone pairs on the oxygen belong then to the oxygen or assigned to the oxygen. And that is going to be true of the oxygen on the right as well. In the double bond, half of the electrons are going to go to the oxygen and half will go to the carbon. Remember that a double bond consists of 4 electrons, so 2 of them will be assigned to the carbon and 2 of them are assigned to the oxygen. Which means that the oxygen has 6 electrons total. It has the 2 lone pairs plus half of the double bond. And then the carbon has 4 electrons assigned to it. So again, half of each double bond, giving you a total of 4 electrons there as well. To assign formal charges, we look at the number of valence electrons, and we take that minus the number of assigned electrons that we looked at on the previous slide. So we're going to take a look at carbon dioxide. And oxygen atom has 6 valence electrons, and we already assigned 6 electrons to that oxygen as well. And so that's going to give us a formal charge of 0. The other oxygen will also have a formal charge of 0. And then the carbon is going to have a formal charge of 0. So the carbon atom has 4 valence electrons, and there were 4 assigned electrons to carbon, which means that we would have 0 for its formal charge, and the carbon for the other structure will also have a formal charge of 0. If we look at the oxygen that's here on the left, then oxygen again has 6 valence electrons, and we're going to subtract 7 assigned electrons. So where that 7 comes from is 2, 4, 6, and then 1 single electron from the single bond. So that's going to give us -1 for its formal charge. And then the other oxygen is going to have a formal charge of +1. So again, oxygen atom has 6 valence electrons. And then there's 2 electrons here, 3, 4, 5 electrons, which means that when you do the math, you would get a +1 for that formal charge. So again, how do we know which is more dominant now that we know what the formal charges are? And the way we determine which is the best Lewis diagram is that it should have the minimum number of formal charges, should have the minimum number of non-zero formal charges. In other words, we would like them all to be 0. However, if a non-zero formal charge must remain, the negative charge must be assigned to the most electronegative atom, and the sum of all the individual formal charges must add up to the charge of the chemical species. So the one that's going to be the best structure is the carbon dioxide, where the carbon is double bonded to the oxygens, and that's because all of the formal charges in this case are 0. Next, I'd like you to determine the formal charge for each atom in the possible Lewis diagrams for the thiocyanate ion, and then determine which of the 3 structures is the dominant one. Press pause, answer your question, and then press play when you're ready to continue. For the structure on the left, nitrogen will have a formal charge of 0. The nitrogen atom has 5 valence electrons, and then there's 2, 3, 4, 5, because remember, we're doing half of the triple bond. So that will be 5 electrons minus 5, which is going to be 0. Carbon has a formal charge of 0. So again, carbon has 4 valence electrons minus 1/2 of all the bonds, which is also 4, for a total of 0. And the sulfur will have a formal charge of minus 1. Sulfur has 6 valence electrons minus 2, 4, 6, and then half of the bond, which is 7. So 6 minus 7 gives us a formal charge of minus 1. Notice that the total here is equal to also the charge on the ion, which is minus 1. For the middle one, the nitrogen now has a formal charge of minus 2. Carbon still has a formal charge of 0, and sulfur has a formal charge of plus 1. And then for the last structure, nitrogen will have a charge of minus 1, carbon will have a formal charge of 0, and then the last oxygen will also have a formal charge of 0. So then the question becomes, which one do we want, or which one would we choose for the most dominant structure? And the dominant structure should be the one on the far right. And the reason is because this puts the negative value on the most electronegative atom, which is nitrogen. This is the end of the video. My name is Mrs. Pudi. Thank you and have a good day.